All right, today we're going to go ahead and talk about how to create the LEGO flying mechanic that you see here on screen. All right, so we'll be starting out using the same script that I've been using for all of my third-person controllers. You've seen additions to it within the Eagle Vision video. You've seen it with the well, you might have caught a glimpse of it with the monitors and mirrors. You've definitely caught it with wall jumping and things like that, but we'll be using that as a base. So all we can do here is move around. We have our camera moving with our mouse perfectly. Our character rotates with it, and we can jump around. That's basically where we're at, where our starting point is. All right. Now, Iron Man here. He, of course, is a character body 3D. His mesh is this little Iron Man Lego figure that I found online. Of course, he has a collision shape. I created a particle for his left and right boot for the thrusters for when we are flying. And then, of course, we got the camera, right? The camera origin or pivot, spring arm, and the camera itself. Right? All typical things that you'd see on the third person controller. The only difference is instead of being a capsule, we actually have this little Lego figure. And I've created two little particles for his feet. That's the only thing that's different here. So where do we start? Well, we're going to start by adding in some more variables. That's the word I'm looking for. If you have the script directly from the third person, you'll notice that I added fly into our states and I turned it into an enum. I don't know why I had it as constants before, but there we go. And we're going to create a few exports and just variables in general. All right, so I went ahead, I just set this under as a group. We're going to have a light speed now. That way we can move faster when we're in the air. I have a boolean for is flying set to false by default. And I have a few exports that I can set. I have the spring length for normal at 10 and for when I'm flying at 20. I have an export for my mesh so I can rotate the actual Lego figure itself. I have an export so I can grab my collision shape and an export for the spring arm. All right. So in Iron Man scene here, I'm just going to go ahead and grab it, open my flying section, and set my variables. So mesh is going to be assigned to our Tony. The collision shape is going to be our collision shape, and the spring arm is going to be our spring arm. All right, so now all of those are set, and that's all the extra variables we're going to need here. All right, so now that we have our variables set here, we can come on down and we want to actually get into our flying state. So we're going to need to modify our check jump and update state functions from the third person controller. So if we come on down, we can take a look. We'll look at check jump. And the first things we want to do is we're going to add two else if functions in here, two else ifs added to this. And we're basically going to say else if our current state is set in the air. So if we're hitting the jump button while we're in the air, then we're going to set is flying to true. We're going to set our y velocity to 0 so we're not getting pulled down by the gravity. And we're going to grab our left and right thrusters and set their emitting to true. So we're going to turn on the particles. Otherwise, if we have hit spacebar, our jump button, and we're currently set in the flying state, so we're flying, right? We're going to turn is flying to false, and we're going to turn our particles off by setting emitting to false. Now, at the moment, if we were to run that and take a look, we can get our particles running, but we're not actually entering that flying state at the moment. Right. So for that, we have to come down to our update states function here. and we're going to change the else block here. So we're actually going to go in and add a simple level inside of this else. We're going to say if is flying, we'll enter the fly state, else we're going to enter the air state. All right, so that alone should control our states, and we should be floating when we hit our jump button again when we're in the air. And we are. Perfect. We can't move around or anything yet because our controls are set to if our state is set to states.air or states.floor. But we can see that we are floating here, and if we hit jump again, we should turn that off, and we should go back to falling back to the ground. As we do. All right. So we can see this is working perfectly fine. Fantastic. So now we actually need the flying portion, because just hovering there is no good. So let's go up to the controls. Coming up to our physics process, we can check. So our normal controls is all inside of an if current state, states.floor, or current state is states.air. Then we do all of our normal controls. And now we need one for when we are flying. Okay, so the first thing we're going to do is do an else if for ourselves. So else if current state is flying, so we can get flying controls. We're going to get the input vector just like we did before. And we're going to get the direction. So these two lines are basically a copy paste from the controls we already have. Difference is I'm going to set the x of this vector 3 to 0 because we don't care about left and right unless you want to be able to move left and right, kind of strafe in the air. Then sure, you can set that up. You can pass in the x if you want. And I'm going to get the y, which is going to be our up-down vector, our up-down part of our input there. And I'm setting a max of input direction.y, which would be down and up, and 0. So basically what this is doing is this is going to set it so that I'm either pressing up or I'm not. Now, if you want to do this separately, then of course you could always just do if input is actually pressed up and just do it that way, which is fine, but I'm just keeping this consistent with the controls that we already have set up. So this is basically allowing me to press up and nothing else is going to matter. That's effectively what the change is going to do here for direction. Now I want to be able to fly in different directions based on where the camera's looking. All right, so if I move the camera left, we're going to turn left. If I'm going to move it right, we're going to turn right. If I move it up, we're going to fly higher in the air. If I move it down, we're going to fly lower. Do that, we're going to need to get some information from what would be our camera, quote unquote, right? Oops, I gotta pull that back. Right, so we're going to get the camera pitch, so that's going to be my pivot, right? My Node 3D that I'm using. And I'm going to get the X rotation value and set that for my pitch. Right, so that'll be our up and down. And then the altitude factor is going to be negative sine of our camera pitch. Right, and we can see here, this is going to get us our forward direction for the altitude controls. And what the sine does here is it converts to a negative 1 to a 1 range. Right, so we're going to get somewhere between a -1 and a +1 as a result here. And then we're setting our velocity.y is going to be equal to our flight speed times our altitude factor times 0.7. If you want to play with this number, you can go ahead and tweak that, see what works better for you. And as you can see here, this is adjusting our sensitivity factor. So this will be our sensitivity for that. Now, if we were to jump and float right now, of course, nothing is going to change a whole lot, but we take a look and you can see if we look, whoops, we were flying there for a second, right? So if I go up, woo, we're shooting up. And if I start looking down, we're going to go straight down, right? So you can see we got this up and down going. We don't have anything else moving, and we're not really flying. Well, I mean, I guess we're kind of flying, but nothing that we would like at the moment. But we can kind of move up and down with our thrusters. All right, so what do we need next? Well, we need to check if we have a direction, right? Just like we do up here, right? We say if we have a direction, then we set the velocity of our x and our z axis. All right, so we can move around. And likewise, we'll do a similar thing here. In fact, we're gonna copy those two lines directly, basically, except we're gonna use our flight speed instead of our regular speed. So if direction velocity.x equals direction.x times flight speed, and velocity.z equals direction.z times flight speed. So just by adding that in there, what do we have now? Well, we can actually move around. We don't stop moving because we don't have that set. But if we hit forward in whatever direction we're looking, we're going to go in that direction. Right? And if our camera is up or down, that's kind of the direction we're going to go. So we have forward movement when we hit forward or up. And we're going up and down based on our camera. All right, so we're slowly getting there. We're making progress towards this flying mechanic. Now, what I want to do, well, let's go ahead and put our else block in here to kind of counteract this. So our else block is just doing our move toward, but we're setting it to zeros, and we're using our flight speed, right? The exact same thing that we've done with our normal movement from the third person. So far we've got a lot of copy and pasting that's working for us. And as you see, if we look up, we're moving up. We look down, we're going down. If we go forward, we're moving forward. And if we don't move, we're just kind of hovering here, aside from the mouse kind of controlling us. All right? And left and right does nothing, down does nothing, and our jump button turns our thrusters off. All right. So at least we can hold still for a moment now that we have that. So let's focus on our actual flying portion. So with this, we're going to rotate our character 90 degrees so he's laying down. And this hit us. Want to make sure I don't leave all that. Right, delete that. So what we're doing so far is I'm getting the camera basis, which is going to be our pivot.globaltransform.basis. And then we're going to grab our mesh itself, right? So the actual Iron Man figure, and set the global transform basis to the camera basis. And we need the 90-degree rotation, which I'm going to use as a tween so that we can get a nice and smooth transition here. So I'm going to create a variable called tween. It's going to be create tween.setEase, and I'm going to set the tween to ease out and set the trans to trans sign. Right? You can set these to whatever you want. You don't even have to set those if you want. You could only just do create tween if that's what you want, and it'll still work perfectly fine. Okay. Next, we're going to get the current rotation of our mesh. Store that. We're going to get our target rotation, or we're going to set that rather, which is going to be the current rotation plus a vector 3 degrees to rad 90 and 0, 0. And then we're simply going to tween the property. Right, so tween property, pass in what you want to tween, which is going to be our mesh. The property we want to do, which is rotation. And we set that to target rotation, and we do it in the span of 0.1 seconds. And if we take a look, you see if we hold forward, we got that nice lean forward happening, which is great. Now, of course, we want to come back up. We don't kind of want to be this little fishy, but I don't know. Maybe you do want to be a little fish. To fix that, as we go, we're going to go into our else block to fix that, and this is just the same thing that we had before. Right, so this is nothing new. Camera bases and our mesh bases, and we're going to create our tween. Right, this is all stuff that we just did. Current rotation. Instead of 90, I'm just passing in a 0. And you can probably do this a little better. But so far, the only difference that we've made here is we turned this 90 into a 0. And that was it. And I've done the tween. In fact, we can just set that even, simplify that. We can just remove the plus vector 3. And just set target rotation equal to current rotation. And that'll work for us here. So if we go ahead and run it, we get into a flying state, we go forward, and as soon as we let go of forward, we're back upright. Right, now we can see we go all the way in to like our knees. When we collide, which is because our collision shape isn't actually changing. Right? So if we were to look at debug and view collision shapes and run this again, we can see our capsule is still straight up and it's not leaning with us. So if you want that to change, then of course we need to add that change in there. And that's what I'm going to do next here. As well as do the spring arm, because I want the camera to pull back when we're flying forward. It's a nicer look. And all we have to do for that, actually, is super simple. We just find our tween. And the next line of it, we do tween.parallel.tween property. And we do it just like we did with any other tween property. So I get the spring arm. I'm going to adjust the spring length, and I'm going to set it to my flying spring length over the course of 0.2 seconds. And to correct that, again, right after our tween inside of our else to reset it, we're going to do the same thing, but set it to the normal spring length property value. Right, so for flying, boom, we got that zoom out, and we'll get that zoom in when we stop. It's nice and smooth, and it kind of makes you feel like you're going a little faster than what you are as well, which is a nice little bonus. So next, we need to set the collision, if you care about that. All right, so I'm just going to get my collision shape and set the rotation degrees. .x equal to 90 and set the position .y equal to 0. And just like that, with the else block. Now these numbers here in the else is going to be, could very well be different for you than it is for me, but I'm going to set the rotation degrees.x to 0 and my position.y to 2.177. And I know that because if I go to my Iron Man scene and I go to my collision shape right now, I can see the default location that I'm using is 2.177. So that's where I got that number from. Now, if we run it and we take a look at the debug capsule here, we can see it lays down and it pops up. Great. Just as it should. Perfect. Now, what you'll notice is when we come out of our flying state here, we're still kind of laying down, so we do have to make a change there. A change for that. And that's going to come in our update state. So if we come down to update state, where we go to else, current state equals error, we need to actually reset a few things here. So these values that I'm grabbing is just the exact same ones that we just created inside of the else block up top where we're not moving. I'm just going to tap those in, and there we go. So we're just creating the tween and performing the tween to reset us. Rotation is being set to vector 3.0, so that is a change. Do not take note of that. And then we're tweening the spring arm back to the normal spring length. And my collision shape is being reset to 0 and 2.177. So now if we try to stop flying while we're going forward, that'll reset itself perfectly fine. All right. Now the last little bit that we need here is to actually control the flying part, right? The velocity. Because right now, if we just look up, we're going to go up even if we're not moving. We're going to go up into our if direction section. And we're just going to set the velocity.y equal to flight speed times our altitude factor times 0.7. Just want to make sure that I didn't have that somewhere else. All right. And then I'm going to change. Actually, I'm not going to change that yet. So we're going to do the velocity.y equals flight speed times altitude factor times 0.7. And for our else, in the else section, we do velocity.y equals 0. It's simple. Now that we're flying, we can see we can just float here now, because if we're not moving, velocity.y is 0, right? That goes into our else. And if we are moving, we're going to look at our altitude factor, which is calculated with our camera. All right, so you can see we're kind of leaning with it now. And now we can just fly up and down. But when we let go, we just kind of hover here. All right, so we have our flying mechanic. We just have one more piece that I want to do, and you see when we're floating here, our flames they're nice, right? They're short, they give us a good idea from our particles, but when we start flying, we have this long tail end going on with it. Now, if you like that, that's fine, you can keep that. I personally don't like this long trail that we have here. If we were doing a jet, maybe I would consider it, but when we're doing a little Lego figure like this with Iron Man, I don't like it. So what I'm going to do is for this last tweak, when we're going in the air, right? So in the if direction, I'm just going to set the thruster lifetime to 0.1. And when we're floating there and just hovering, I'm going to reset them to their default, which is 0.4. That's what I'm currently using. So now if I take a look, if I float, you can see they look exactly the same, but now when I fly, they're going to remain much shorter, and I'm not going to have that super long trail that I had before. All right, and we stop, and here we go again, right? Same size, it looks normal. All we've done is just get rid of that long trail that we had before. All right, hopefully you were able to follow along with that. We kind of went back and forth, so we set something, and then we immediately went to the else block to reset it. And then we set the next piece, and we reset that. We set the next piece, and we reset that. So we kind of went back and forth with that. But we basically just counted out each other for when we were pressing a button and when we weren't. Right, hopefully that made sense, and hopefully you didn't get too confused with that. But there we go. Now we have ourselves the Lego flying mechanic for our little Iron Man guy here. All right, so that's it with this. Take care. Have yourselves a good one, and I'll see you guys next week.